Alright, guys, so let's go ahead and get started on example 1 here. Now, on this one, it says that suppose we want to go ahead and find sine of A based on triangle ABC, and here's our triangle ABC. Now, they are asking us to find sine of A, and I'm going to go ahead and actually write our abbreviation of SOHCAHTOA here. So we have SOHCAHTOA. And since they said that we want to go ahead and find sine, I'm going to go ahead and be working with this one here, with So I know in this case that whenever we're working with it's basically sine of A, which is whatever our angle measures, equals our opposite side over our adjacent side. Not adjacent side, over our hypotenuse, I'm sorry. Hypotenuse. So then in this case, the only thing that's left for us is to determine which ones are opposite, adjacent, and hypotenuse. Now, they did say that we are basing this off our angle A, which means that the side opposite to my angle A is going to be the opposite side. So if I look at the side opposite to angle A, I will determine that 3 in this case is our opposite, which means that the 4, which is the side that's next to the opposite side or that shares the 90-degree angle, would be our adjacent side. And I'll go ahead and write adjacent. And in this case, the final one, which is the hypotenuse, is the side that's opposite to the right angle, which in this case would be the 5. So the side opposite to our right angle would be the hypotenuse. So then in this case, they're asking us to find sine of A. So all they're doing is basically having us build the fraction here. So we have sine of A equals the opposite. Now the opposite side has a measurement of 3. So I'll go ahead and do 3 over my hypotenuse, which has a measurement of 5. So in this case, our final answer would be sine of A equals 3 over 5. And it's that simple. Now, this is just based off angle A. Now, let's say I wanted to go ahead and base this off angle B. Now, if you take a look, this is actually the same triangle. I'm actually now focusing on angle B. The previous one, we had focused on angle A, but now I'm focusing on angle B. So then, what changes here is the opposite and the adjacent side based on the angle. So now my focus, I'm viewing this from angle B, which means that the opposite side from angle B is now going to be the 4. So the side opposite to that, opposite to our given angle, would be 4. So this here is going to be my opposite side now. Now, the other side, in this case, the one that shares the 90-degree angle, or the one that's opposite to the opposite side, not opposite, but next to the opposite side, would be known as our adjacent. And the side that doesn't change would be the hypotenuse. In this case, the side that's opposite to the 90-degree angle, which is the 5. So then in this case, if I want to go ahead and find sine of B, once again, I'll go ahead and write SOHCAHTOA. And we said we are working with a sine. So then in this case, we are looking for our opposite and our hypotenuse. So I'll go ahead and rewrite this. So we have sine of B equals the opposite side over the hypotenuse. So then in this case, sine of B is equal to 4, which is my opposite side, over 5. And this here would be my final answer. Now, if we compare both of these answers, we actually have different ratios. This one's 4/5 and this one's 3/5. And those actually are different because it's all based on the angle you're given. So as you guys can see, this is basically the same triangles with different ratios, with different sine ratios. And that's supposed to be sine with SIN. So sine with different sine ratios depending on the angle. So we're looking for the same thing. We're looking for sine